Maintenance tips. When stopping the pump during breaks, at the end of the day, or especially in preparation for storage, make it a habit to stop the displacement pump rod at the bottom of its stroke. This helps prevent material from drying onto the rod, which could in the future damage the upper packings. A small amount of oil should be added to the upper packing nut daily to protect the rod and packings from premature failure. Check the tightness of the upper packing nut daily. A loose packing nut will allow fluid to escape past the packings and cause the oil reservoir to overflow with fluid. A loose packing nut will also cause premature packing failure. Check the hydraulic oil level while the system is cold. Remove the hydraulic tank's oil inspection plug and verify the oil level. Never raise the oil level past the inspection port, as the oil will expand as it warms and the excess will flow out the vent. Change the hydraulic oil filter every 500 hours of operation and the hydraulic oil every 1,000 hours. Fill the reservoir with a good quality ISO 68 hydraulic oil for warm weather use and an ISO 46 for colder temperatures. Relieve the hydraulic oil pressure from the system before servicing any portion of the power pack. Check the engine oil daily. Follow the surface specifications as outlined in the engine owner's manual regarding oil, oil filter, and air filter maintenance schedules. Contaminants that may fall into the drum, such as ballast rock, fasteners, or twigs, will eventually be sucked up by the pump. Rarely do these contaminants cause damage, but they will affect the displacement pump's performance. As the displacement pump performs its work, several stainless steel balls raise and fall back onto their seats. If an obstruction restricts either ball from properly returning to its seat, the pump will respond with a reduction in its ability to create vacuum, pressure, and flow. Two symptoms of pump obstruction are a noticeable surge in the spray fan, or the hydraulic motor will continue to stroke after the gun trigger is released. All members of the spray crew should know how to field strip, clean, and clear the pump from contaminants. The displacement pump is designed with this very feature in mind and should not require the shop mechanic to perform this task. If the pump contamination is suspected, begin by stopping the displacement pump near the middle of its stroke. Raise the displacement pump from its container and move the sprayer to an area where the service can be performed. Lower the displacement pump to a comfortable height for field stripping and stop the engine. Release the pump pressure by first pulling the gun trigger and then opening the pressure relief valve at the pump outlet. Once fluid has stopped flowing from the open pressure relief valve, loosen the intake valve by striking the lugs in a counterclockwise direction using a hammer. Once the intake valve is loose, disconnect it completely from the cylinder by hand and set it onto a clean, level surface. By hand or with a plier, lift the intake ball cage from the intake housing. As the ball cage is being pulled out, account for 3 identical shims. Typically, you will find 2 shims on the top and 1 shim beneath the ball cage. The position of the shims determine the length of ball travel, an adjustment that can be made for fine-tuning the pump for different materials. Reach into the intake housing and remove the lower intake ball. If an obstruction is found, clear the contaminant, reassemble the intake valve, and return it to the pump cylinder. Tighten the intake valve firmly with a hammer and put the pump back into use. If no obstruction is found in the intake valve, proceed to the next step by removing the cylinder lock pin from the upper housing. Alignment of the cylinder may be necessary for the pin to be easily removed. Using a pipe wrench, large plier, or by hand, rotate the cylinder in a counterclockwise direction, causing it to unscrew from the upper housing. Once unthreaded from the upper housing, pull the cylinder down until it is separated from the displacement rod and piston. By placing one wrench on the flats of the displacement rod and another wrench on the flats of the piston, separate the two from each other. Remove the upper ball from its cage and clear any obstruction found in the piston. Reassemble the now clean piston onto the displacement rod. Slide the cylinder back into place and rethread it onto the upper housing. Use a pipe wrench or plier to seat the cylinder fully into the upper housing. Once fully tightened, back the cylinder off about 1/4 of a turn to where the lock pin can be easily reinstalled into the upper housing. Reinstall the clean intake valve back onto the cylinder and put the sprayer back into service, always remembering to follow the pump priming process as described earlier. As a normal maintenance issue, The displacement pump packings will require replacing as they become worn. A common symptom requiring packing replacement is a gradual decrease in pressure over time. However, severely worn packings that should have been replaced earlier can suddenly tear, causing excessive leakage at the wet cup. There is no set time schedule for packing replacement due to the many types and different levels of abrasiveness that cold process materials are formulated with. The packing should be inspected for wear on a schedule that offers the least amount of downtime, such as immediately after or in preparation to an upcoming spray job. First, flush the pump with clean solvent. This will make the internal cleanup process much easier once the pump is removed. Stop the displacement pump near the bottom of its stroke and follow the pressure relief procedure. Remove the fluid hose from the displacement pump outlet. Remove and thoroughly clean the displacement pump intake tube assembly from the intake valve. Remove the coupling cover's locking clip pin. Slide the coupling cover up and remove the coupling assembly from the motor and displacement shaft. The coupling cover locking pin can be used to hold the coupling cover in the disconnect position. Slowly cycle the hydraulic motor away from the displacement rod. With a blunt punch and hammer, loosen the wet cup packing nut by tapping it in a counterclockwise direction. Next, remove the intake valve assembly using a hammer to drive the lugs in a counterclockwise direction. Disassemble the intake valve by removing the ball guide, ball, carbide seat, and the 3 shims used to set the ball travel distance. Remove the 2 O-rings from the ball guide, the single O-ring seal from the carbide seat, and the O-ring seal from the bottom of the cylinder. Align the flats of the cylinder and remove the sleeve locking pin. Turn the cylinder counterclockwise, separating it from the upper housing. Once unthreaded, pull down on the cylinder, removing it and the displacement rod from the upper housing. Separate the displacement rod from the cylinder by driving the rod end onto a wooden or plastic block. Caution should be given during this procedure to prevent damage to the rod end. Finish removing the wet cup packing nut from the throat cartridge, exposing the upper packing stack assembly. Remove the upper packing stack from the throat cartridge using a small screwdriver or mechanic's pick. Unthread the throat cartridge from the outlet housing and remove the throat cartridge O-ring seal. Using 2 wrenches on the flats, separate the piston from the displacement rod. The flats of the piston may also be held in a vise during disassembly. Remove the ball and packing stack from the piston. Separate the outlet housing from the tie rods by removing the 3 tie rod lock nuts. The outlet fitting assembly may remain on the housing or removed if necessary for cleaning. Thoroughly clean and inspect all parts to the now disassembled pump. Before beginning the repacking process, identify all the parts to your repacking kit. Your kit includes the piston ball, intake valve ball, 2 metal female glands, 2 male metal glands, 2 white Teflon packings, 8 leather packings, 1 throat seal cartridge O-ring seal, 1 upper cylinder O-ring seal, and 4 identical O-ring seals used as the lower cylinder seal, ball cage seals, and carbide seat seal. Separate the packings into 2 even stacks. Lubricate the leather packings with a light coating of oil. Do not soak the leather packings, as this will cause them to swell and make assembly difficult. With the piston head on a flat surface, install the metal female gland. White Teflon packing, 4 leather packings, and the metal male gland onto the piston with the V of the packings pointed down. Place the piston ball into the ball guide and add 1 drop of thread sealant to the piston threads. Install the piston onto the displacement rod and torque to 200 foot-pounds. Once assembled, verify that the piston ball is free to travel by tilting the rod back and forth, listening for ball travel. Next, install a new O-ring onto the throat cartridge. Assemble the upper packing stack by first inserting the metal male gland into the throat cartridge well with the point of the V facing up. Follow the male gland with the 4 leather packings, 1 white Teflon packing, and finish with the metal female gland. Assemble the wet cup packing nut onto the throat cartridge and tighten by hand. Install the now completed upper packing assembly into the outlet housing. Tighten only the throat cartridge using a blunt punch, plier, or pipe wrench. The wet cup packing nut will be adjusted for tightness after the displacement rod is installed. Install the new upper and lower cylinder O-ring seals and set it upright onto a flat, hard surface with the fine threads of the cylinder facing up. Lubricate the piston with light oil or grease and insert it into the taper of the cylinder. Using a non-metal hammer or a block of wood used as a soft bumper between the hammer and the displacement rod end, drive the piston into the cylinder until the packing stack first passes the taper. At this point, check for and remove any pieces of packing material that may have been sheared during the insertion process. This is a somewhat normal occurrence as the packings seat themselves onto the cylinder wall. Finish driving the displacement rod to about the middle of the cylinder and verify that the rod is centered. Install the outlet housing onto the tie rods and secure with the 3 self-locking nuts. Lubricate with oil or light grease and insert the displacement rod into the outlet housing by pushing up on the cylinder body. Verify that the cylinder is not cross-threaded to the outlet housing and begin threading. You should be able to start the threading by hand. Continue to thread the cylinder into the outlet housing until it bottoms out. A plier or pipe wrench will be needed to complete the tightening process. Once bottomed out, back off the cylinder until the flats align with the locking pinhole and insert the lock pin. The pin should insert smoothly with little resistance. Align the displacement pump rod with the hydraulic motor rod and install the coupling assembly. Secure the assembly by lowering the coupling cover and locking it into place. Tighten the wet cup packing nut by hand, plus another 1/2 turn using a plier, pipe wrench, or hammer and blunt punch. The wet cup should be checked daily to ensure proper tightness. A loose wet cup results in poor packing seal and will allow fluid to pass past the packings and overflow the wet cup with material. Assemble the intake valve by first examining the carbide seat for wear. The seat is reversible and should be installed with its best side facing up. A worn seat requires a replacement. Next, install the carbide seat O-ring seal so that it sets in the outer groove of the seat. The thin metal shims in the intake valve assembly are used to control the travel distance of the ball. A shim or shims added below the ball cage will increase the travel distance, while adding the shims above the cage will decrease the distance. High viscosity materials such as mastics respond favorably to a mid-range ball travel, while lower viscosity materials such as a primer respond better to a short travel. For the spray application of heavier cutback asphalt materials, we recommend the following sequence for shim placement. Place the intake ball onto the carbide seat. Set 1 shim on top of the carbide ball seat. With new O-rings installed onto the ball cage, insert the cage into the valve housing. Place 2 shims on top of the ball cage to finish completing the intake valve assembly. Screw the intake valve assembly onto the cylinder and tighten with a hammer. The intake valve should be checked daily for tightness. Once the intake valve has been tightened, install the intake tube. Verify that the screen has been thoroughly cleaned and inspected. Add about 1 ounce of lubricating oil to the wet cup. This is to ensure that a film of oil remains on the displacement rod to prevent bare metal exposure to the elements. Once the pump has been returned to service, check the wet cup packing nut for tightness after a few minutes of work. The Hennes-Johnson Equipment Company wishes to sincerely thank you for viewing this presentation. We look forward to serving your cold process application needs in the very near future. Everyone here at Hennes-Johnson Equipment wishes to sincerely thank you for taking the time to view this presentation. We all look forward to serving your cold process application needs in the very near future.